It's just incredible how fast AI is evolving, isn't it? I mean, not long ago, basic AI help felt like this huge thing.
Yeah.
Now we've got these, well, thinking models doing incredibly complex stuff,
hmm
generating code, writing creative text, even helping with science.
It's a massive leap, and the demand for, power and data handling, it's just gone astronomically.
Totally. The sophistication just keeps climbing. It needs a whole different kind of infrastructure underneath it all.
It really does. And well, that's exactly what we're digging into in this deep dive.
Exactly. We're looking closely at Google's seventh generation TPU. They call it Ironwood.
hmm
Now, Google's earlier TPUs, they were really great at training AI models, right? That whole learning phase.
Yes, that was a primary focus.
But Ironwood seems like a significant pivot.
It is, absolutely. Ironwood is actually the first one they've specifically built for inference.
Inference.
Okay, think of it like this. Training is like teaching the AI, right? Getting it to learn. Inference is when the AI actually uses that learning.
Ah, okay. To generate insights, make predictions.
Exactly, to give interpretations. It's AI moving past just, spitting out data for us to figure out. It's starting to provide understanding itself.
So it's not just like a speed bump for current AI.
Hmm.
It's horsepower for this whole next level of proactive AI.
Precisely.
And for everyone listening, if you want to get what's happening at the cutting edge without getting totally lost in technical jargon,
Yeah, we'll try to avoid that.
that's our goal today, to really break down why Ironwood is such a big deal.
Definitely. And before we jump right into the tech specs, let's quickly mention our sponsor for this deep dive, StoneFly.
Right.
StoneFly provides these really robust, high-availability IT infrastructure solutions. Basically, they keep your crucial data safe and accessible.
Which is pretty important these days.
Absolutely critical. Their Stone Fusion operating system, it's intelligent. It's designed to support these data-heavy operations like AI wherever they need to run. They offer a whole suite of things: cloud services, enterprise storage, backup and disaster recovery, hyper-converged systems. The focus is always on that always-on high-performance data management.
Which, yeah, sounds essential for the kind of advanced AI we're talking about with Ironwood.
Exactly. So, all right, Ironwood. Google's 7th gen TPU announced at Cloud Next. What's the core thing about it?
You said inference optimization.
Right, that's the key. Previous TPUs were versatile, sure, but Ironwood is purpose-built to run those trained models efficiently and, importantly, at scale.
At scale, yeah. I saw the configurations there, planning clusters of, what was it, 256 chips.
And a massive 9,216 chip version, too. It should be available for Google Cloud customers later this year.
Wow, 9,216. That's a lot of chips. Google sounds really pumped about it.
They do. Their Cloud VP, Amin Vadat, he called it their most powerful, capable, and energy-efficient TPU yet.
Right, and specifically for thinking inferential AI models at scale. That phrase, at scale, really jumps out.
It does. It really signals this shift. Google talks about the age of inference.
Okay, the age of inference.
Yeah, like you said earlier, it's a fundamental change. We move from AI mostly giving us raw data to interpret.
To AI actually generating the insights, the understanding itself, like an AI collaborator.
Kind of, yeah. Synthesizing information, providing meaningful answers directly.
So Ironwood isn't just speeding up today's AI chatbots, it's building the foundation for this more insightful AI future.
Definitely. And it seems particularly aimed at generative AI, which is driving so much of this right now.
Makes sense. Those models are complex.
Incredibly complex. The processing, the data movement, they need infrastructure that can handle massive parallel work and super fast data transfer.
Which sounds exactly like what Ironwood is designed for.
That's the idea.
Okay, let's peek under the hood then. What are the key tech specs, the features that give it this power? I saw some really big numbers.
Oh, yeah. The numbers are impressive. Each chip, a single Ironwood chip, has a peak compute power of 4,614 TFLOPs.
Teraflops. Okay, that sounds like a lot.
It's immense processing power on one chip, and it's paired with 192 gigabytes of dedicated high-bandwidth memory HBM.
192 gigs of HBM per chip.
Per chip. And the bandwidth, the speed of that memory, is approaching 7.2 terabytes per second.
7.2 terabytes per second.
Yeah! Imagine this incredibly wide, fast highway directly into the processors. It stops data from becoming a bottleneck.
Right. You need that speed to feed these huge models.
Absolutely. And there's another interesting bit, an enhanced sparse core.
Sparse core.
Yeah, it's a specialized part of the chip optimized for handling, well, sparse data. Think data with lots of zeros or empty values.
Okay, like in recommendations.
Exactly. Advanced ranking recommendation engines, that's where it started. But with Ironwood, what's interesting is they're expanding its use.
Oh, beyond AI recommendations.
Yeah, into things like financial modeling, even scientific simulations, so that specialized core is finding broader application.
Huh, that's unexpected. So it's not just movie suggestions anymore.
Not at all. It shows how adaptable this specialized tech can be for other complex computing problems.
Interesting. What else? You mentioned communication between chips.
Right, the ICI, or inter-chip interconnect. That lets the chips in a cluster talk to each other really fast.
And that got faster too.
Yep, bandwidth is up to 1.2 terabits per second bidirectional. Crucial when you have thousands of chips working together on one problem.
Makes sense. They all need to sync up.
And fundamentally, the whole chip layout is designed to minimize how far data has to physically travel on the chip.
Shorter paths mean faster processing.
Faster processing and, crucially, big energy savings. Less movement equals less power used. Google really highlighted the efficiency gains.
Efficiency is huge, especially with AI's power needs going up.
Yeah.
So, speaking of scale, that 9,216 chip cluster, what's the total compute power there?
Get ready for this number. When you scale it up that far, you're looking at 42.5 exaflops.
Exaflops. Okay, I need context for that.
Well, Google put it this way. It's over 24 times the compute power of a comparable setup in the world's current fastest supercomputer, El Capitan.
24 times per pod.
Per pod, yeah. El Capitan delivers about 1.7 exaflops per pod. So 42.5 exaflops from Ironwood. It's just sheer processing muscle.
That's kind of hard to wrap my head around.
Yeah.
And the power efficiency improvements. You said they were significant too.
Very significant. Ironwood delivers twice the performance per watt compared to Trillium, their previous TPU, which only came out last year.
Double the efficiency in just one generation.
Yep. In a world where getting enough power is a real bottleneck for deploying AI, doubling efficiency is, well, it's a game changer.
No kidding.
And compared to their first cloud TPU back in 2018, Ironwood is nearly 30 times more power efficient.
30 times. Wow. How do they even cool these things?
Advanced liquid cooling. You have to sustain that kind of performance without overheating.
Right. So way more power, way less energy needed. That's serious progress. How does this fit into Google's bigger AI picture? They talk about AI hypercomputer pathways.
Yeah, good question. Ironwood is going to be a core part of Google's AI hypercomputer.
Which is?
Think of the hypercomputer as this super scalable modular computing system within Google Cloud, built specifically for the toughest AI jobs.
Okay, like a specialized cloud environment.
Sort of. And to manage all those Ironwood chips working together, they use their Pathways software.
Pathways. That's the runtime.
Right. It's the machine learning runtime designed for this massive distributed computing. It lets developers potentially use hundreds of thousands of Ironwood chips together.
Or hundreds of thousands. Wow.
Tackling really huge AI problems.
So it's not just the chip itself, it's the whole system. The chip, how they're connected, the software managing it all.
Exactly. It's the whole integrated stack working together.
A comprehensive approach for, well, the next wave of AI.
That's the goal.
Okay, this sounds incredibly powerful. But let's bring it back down to earth a bit. What does this actually mean? What kind of impact could we see from this kind of leap in AI accelerators?
Well, these improvements, the raw power, the huge memory, the fast networking, the efficiency, they directly tackle the bottlenecks holding back today's most advanced AI.
Like LLMs, mixture of experts models.
Precisely. Those models are hungry for exactly this kind of capability. Google already pointed out that their top models, like Gemini 2.5,
Yeah.
and even AlphaFold, the protein folding AI,
Oh, right. That was huge.
they already run on TPUs. So Ironwood just opens the door for even bigger breakthroughs.
Both for Google's own researchers and for their cloud customers, presumably.
Absolutely. Imagine what even more advanced AI could do across different industries when this kind of power becomes more accessible.
It's definitely exciting to think about. And, it strikes me how the kind of infrastructure Ironwood needs, high performance, scalable, always available, really echoes what our sponsor, StoneFly, focuses on.
That's a really good point. StoneFly's whole mission around providing that high-performance, flexible, always-on IT infrastructure, it's exactly what's needed for these demanding AI workloads that Ironwood enables.
Right. There's Stone Fusion OS. You mentioned it's designed for data-heavy tasks.
Yeah, making sure those complex AI computations run smoothly, reliably, that's critical when you're dealing with the huge data sets and processing involved in AI inference.
And security must be a big concern, too, with all that valuable data and AI work.
Huge. And that's where things like StoneFly's secure air-gapped vault and their data immutability features come in.
Air-gapped, meaning offline protection.
Exactly. Protecting that critical AI training data, the models, the insights they generate, protecting it from cyber attacks like ransomware. It ensures the AI results are reliable and trustworthy.
Makes sense. You need that solid, secure foundation. Okay, so if we were to wrap up this deep dive on Ironwood, what are the main takeaways?
I think the big picture is this. Ironwood is a really significant step forward for AI chips. It's specifically built for inference, which is becoming more and more important.
Right, running the models, not just training them.
Exactly. And it offers this unprecedented level of compute power and energy efficiency. It's really paving the way for this new era you mentioned of more proactive, more insightful AI.
Yeah, that transition from AI just giving us data to AI actually generating understanding.
Hmm.
That feels like the core shift.
It is. It's profound.
So on that note, maybe a final thought for our listeners to chew on.
Hmm.
With this kind of power and efficiency becoming available for AI inference, how could that change things in your field or just in your daily life?
Hmm.
What new possibilities does this unlock? Things maybe we haven't even really thought of yet. It's definitely something to keep an eye on as this tech just keeps accelerating.
Absolutely. It's a fascinating space. Keep exploring these AI advancements and, the crucial infrastructure that makes it all possible.